Good morning viewers, welcome to Physics World by Sudhakar. In this video session, we are going to solve, and the next coming few videos also, I'll be solving some previous year's questions from IIT JAM in Thermodynamics. Okay, in Thermodynamics chapter, what all questions have come in previous years of IIT JAM, I'll be solving. Okay, so initially, at for every problem, I'll give you the necessary theory behind it also. Okay, now we know that the ideal gas equation PV equal to, for ideal gas, PV equal to, right, nRT. PV equal to nRT. Now, I'll define what is known as bulk modulus. Okay, what is in general bulk modulus? Bulk modulus is, right, B equal to, how do you define, right, normal stress by volumetric strain. This is in general bulk modulus anywhere. Okay. For gases, of course, we have isothermal bulk modulus and adiabatic bulk modulus, etc. In general, bulk modulus definition is normal stress. Normal stress means normal force per unit area. That is nothing but pressure. Okay, change in pressure, dP. Okay, normal stress is nothing but dP. Okay, by volumetric strain. Strain is what in Young's modulus. Okay, longitudinal strain, change in length by original length. In bulk modulus, change in volume by original volume. Okay, so volumetric strain is nothing but change in volume dV by initial volume V. So dV by V is volumetric strain. So bulk modulus B equal to, this V goes up and becomes, okay, V into dP by dV. dP by dV. Okay, right now, whenever for a closed system, whenever you increase the volume, okay, pressure decreases. Whenever you decrease the volume, pressure increases. So change in pressure and change in volume are usually with opposite signs. So I'll put a minus sign here to indicate that change. Minus V, right, dou P by dou V or dP by dV. Okay, this is known as, right, bulk modulus. Bulk modulus in general definition. Okay, in an isothermal process, I'll define isothermal bulk modulus BT as equal to minus V dou P by dou V at constant T. Okay, adiabatic bulk modulus BS is defined as BS equal to minus V dou P by dou V at constant entropy means S. Okay, in adiabatic process, in a reversible adiabatic process, entropy remains constant. So BS is, that is adiabatic bulk modulus is minus V dou P by dou V at constant S. Okay, now reciprocal of this, reciprocal of the magnitude of bulk modulus is defined as I compressibility. Okay, compressibility K in general is defined as what? Reciprocal of this magnitude, that is 1 by V dou V by dou P. Okay, 1 by V dou V by dou P is known as I compressibility of the gas. Okay, compressibility of the gas. Okay, if it is isothermal compressibility, KT, I'll write KT equal to 1 by V dou V by dou P at constant T. Adiabatic compressibility, okay, BS Ks equal to minus V dou P by dou V at constant S, I write. Okay, reverse is 1 by V dou V by dou P at constant S becomes adiabatic compressibility. Okay, 1 by V dou V by dou P at constant T becomes isothermal compressibility. Okay, now in general, for a gas, ideal gas, we have PV equal to nRT. We have PV equal to nRT in general for an ideal gas. Now we will see what happens. Okay, so take PV equal to nRT. Okay, in an isothermal process, temperature remains constant, so T is constant, N is number of moles is also constant, R is constant, so I can take PV equal to some constant C. Now differentiate this equation, right, PdV plus VdP equal to, right, constant, if you differentiate you will get 0, or PdV equal to minus VdP or minus V dP by dV at constant T. We are defining it as what? Isothermal bulk modulus. So isothermal bulk modulus BT equal to minus V, right, dP by dV is equal to bring this dV to the side, minus V dP by dV is nothing but isothermal bulk modulus, nothing but pressure. So what is isothermal bulk modulus of an ideal gas? Okay, let it be any number of moles. Okay, right? Isothermal bulk modulus is equal to PV, right? Okay, similarly, adiabatic bulk modulus. In an adiabatic process, right? In an isothermal process we have, right, PV equal to constant, right? In an adiabatic process, PV to the power gamma equal to constant. Okay, PV to the power gamma equal to constant CV, right? Okay, now differentiate this equation, P into, okay, gamma V to the power gamma minus 1 into dV plus V to the power gamma into dP is equal to 0. Okay, this is nothing but gamma P. Okay, V to the power gamma minus 1 dV is equal to minus V to the power gamma into dPi, right? Okay, now here V to the power gamma is there, V to the power gamma minus 1. If you bring this V to the power gamma minus 1 to this side, V to the power gamma by V to the power gamma minus 1, that is V cube by V square, or V to the power 4 by V to the power 3. Okay, nothing but V only will remain. So gamma P dV is equal to minus V dP. So what is adiabatic bulk modulus? What is adiabatic bulk modulus means? Okay, now take this dV to the other side. Gamma P equal to minus V dP by dV. Because this process is an adiabatic process, I will put constant S here. So what is adiabatic bulk modulus of a gas? Adiabatic bulk modulus of a gas is gamma P. Isothermal bulk modulus of a gas is pressure itself is isothermal bulk modulus. Adiabatic bulk modulus is gamma times the pressure, okay, of the gas. Okay, so this is the relation between the relation of what you call the adiabatic bulk modulus and isothermal bulk modulus. Okay, with this background we will go to a previous JAM problem, okay, which is given here like this. Isothermal compressibility of a gas is defined as, that's what he is saying. Okay, isothermal compressibility of a gas is defined as he is giving the definition itself as KT equal to, okay, KT equal to 1 by V dV by dP at constant T. Okay, isothermal compressibility of a gas is defined as KT equal to 1 by V dV by dP at constant T equal to as constant T. That's what the definition itself he himself has given. Now he is asking is, what is the isothermal compressibility for N moles of an ideal gas? For N moles of an ideal gas, right, isothermal compressibility KT equal to, right, 4 options he has given. What are the 4 options given by him? Here we have A equal to 1 by P, B equal to N by P, okay, C equal to minus 1 by P, D equal to minus N by P. Okay, isothermal compressibility of a gas, he himself has given the definition. For N moles of an ideal gas, what is the isothermal compressibility is asking. Now, we have already derived here. Okay, we can directly use the relation. Okay, isothermal compressibility 1 by V dou V by dou P at constant, nothing but reciprocal of bulk modulus. This is nothing but reciprocal of bulk modulus. For an ideal gas, we have got the isothermal bulk modulus as what is equal to pressure minus V dP by dV at constant equal to pressure of the gas we got. So what is V into dP by dV at constant T equal to minus P it will be. Okay, or 1 by V dP by dV at constant T equal to minus 1 by P it will be. Take the reciprocal of it. Okay, right? If he has asked for next year, he may ask what you call adiabatic bulk modulus. Adiabatic bulk modulus means, right, that what you call PV to the power gamma factor also will come into the picture. Now this is one direct relation, or then now and here itself we can derive. Okay, we can derive the relation like this. For an n moles of an ideal gas, okay, PV equal to nRT. Okay, so PdV plus VdP is equal to nRdt. Isothermal process means dt equal to 0. So PdV equal to plus VdP is equal to 0, or PdV equal to minus VdP. What is isothermal compressibility? 1 by V dV by dP. So bring that minus VdP to LHS and take this P to the other side. So 1 by V, okay, dV by dP at constant temperature. This is nothing but isothermal compressibility K is equal to how much, right? Minus 1 by P. Okay, we have taken for n moles only. So what is the option here? Minus 1 by P. Okay, straightforward, simple question. Okay, without defining what you call himself, he has defined isothermal compressibility. Even if this expression not given also, we should remember it in mind. Okay, this time he has asked isothermal compressibility. You try for adiabatic compressibility. Okay, adiabatic bulk modulus, isothermal bulk modulus, like that. Okay, right, we'll go through the next problem. A cylinder contains 16 grams of oxygen. A cylinder contains 16 grams of oxygen gas. Okay, the work done when it is compressed to 75% of its initial volume at constant temperature of 27 degrees Celsius is, then the work done when it is compressed to 75% of its 75% of initial volume at a constant temperature of 27 degrees Celsius is how much he is asking. He has given 4 options. Okay, now this is nothing but at a constant temperature means it is isothermal compression. What is the work done in isothermal process? Work done in isothermal process is dW or W equal to, right, dQ equal to nRT log Vf by Vi. Okay, final volume by initial volume to the base E. Okay, 16 grams of oxygen. What is molecular weight of oxygen? O2. Okay, atomic weight of oxygen is 16, molecular weight is 32. Means 32 grams of oxygen gas is equal to 1 gram mole. Okay, he has taken only 16 grams, so it is half mole. So N equal to half. Be careful here. Okay, in taking considering how many moles only, most of students go wrong or do that silly mistakes. Okay, 16 grams of oxygen means I have seen many students suddenly taking it as 1 mole. Okay, no, oxygen means 16 will come to their mind. They'll take it as 1 mole. It is oxygen gas, O2 gas. Molecular weight is 32, 16 grams means half mole. So N is equal to half mole into R is 8.314 joules into log. Okay, what is final volume? The gas is compressed to 75% of its initial volume. Okay, initially the gas is 75% means what? Initially if the gas is 100 liters, right, it is compressed to 75 liters. Initially if it is 4 liters, it is compressed to 3 liters. Okay, that is final volume is, I'll take it as 4V. Okay, initial volume is 4V. It is compressed to 75% of its initial volume means what? To 3V. That is nothing but 4 by 3. Okay, log 4 by 3 to the base E. Okay, so this is nothing but, if you simplify, the remaining thing is nothing but mathematical part. Okay, half into 8.31 into Okay, right? Temperature is also there. No, sorry, temperature T is there at a constant temperature of 27 degrees Celsius. 27 degrees Celsius means how many Kelvin? 300 Kelvin. So the 300 also should come here. Okay, 300 also should come here into log 4 by 3 is nothing but log 4 minus log 3. Okay, final, log, what is initial volume? Initial volume is, it is compressed to, that is final volume is less than the initial volume, isn't it? So we should take here, final volume is 75% means 3V. Okay, right, log 3 by 4 it should be. Log 3 by 4 to the base E, that is log 3. Log 3 minus log 4. Log 3 minus log 4. Log smaller quantity by bigger quantity, you will get a negative term. Log 3 value, log 4 value. In the beginning of thermodynamics only I told, it is always better to remember log 1, log 2, log 3, log 4, log 5. Okay, now log 5 is also not required. Up to log 4 better to remember. Natural logarithms. Log 1 to the base is anyway 0. Log 2 to the base is 0.693. Log 3 to the base is 1.098. Log 4 to the base is nothing but log 2 square. 2 log 2. Okay, 2 log 2, that is 1.386 you will get. Remember these things. Okay, they will be extremely useful in solving problems. Okay, so log 3 minus log 4 means this is nothing but 150 into 8.31 into log 3 value is 1.098 minus log 4 to the base value is 1.386. 1.386. Okay, so you can take this approximately as 1. Okay, and this as 1.1 minus 1.4 you can take. 1.4 minus 1.1, that is 0.3 minus 0.3 you will get. So you approximately you take this solution as 150 into 8.31 into, right, that 0.3 minus sign will be there. Okay, negative work means what? Okay, 0.3 into 150, 3 by 10 into 150, nothing but 50. Okay, 50 into 8.31 with minus sign. Work done is negative means what? Work is done on the system. It is an isothermal compression means we are doing work on the system. We are doing work on system. So work done on the system is negative. That's why we are getting negative sign here. 50 into 8.314, simplify and choose the correct option given. Okay. Thank you. We will continue with some more problems in the next video.